Hi guys, so the next part of our unit 3 is module 2.2, and this one is talking about percents greater than 100% and less than 1%. So percents greater than 100%, less than 1%, and I'm going to show you how they can be modeled on a 10 by 10 grid. So look at our learning target. I can understand that percents can be greater than 100% or less than 1% and use 10 by 10 grids and bar diagrams to represent them. Okay? Vocabulary is going to be percent. And we've already talked in the earlier lesson in module 2.1 that percent is nothing but part out of a whole, and that whole is 100. So it's parts per 100. That is what a percent is. Okay, so let me take you to my whiteboard and we are going to look at this question. All right, and we're going to talk about percents that can be greater than 100%, because very often children, when they see 125%, they're like, how can that happen? But yes, you can have a percent which is more than 100%. Okay, so the table shows the total rainfall during April for a certain city for 3 different years. All right, so I can see the rainfall in 2017 and I can see the rainfall in 2018 and I can see the rainfall in 2019. All right, so if I am calculating the rainfall over here, the percentage, you're going to look at the ratio and we're going to compare the rainfall in 2017 to 2018. So let's look at that, and we're going to see in 2018 it rained less than it did in 2017. To compare the rainfall in 2018 to 2017, what we're going to do is we are going to use the ratio. So we are comparing 2018 to 2017. That's what we are comparing. All right, so when I'm comparing these 2 years, I'm going to look at the rainfall in those years. We're going to write the part. So in 2018 was how much? It was 3. Okay, and I'm going to write the ratio of 3 to 4, because over here, so look at this part. So ratio is 3 to 4. All right, so if I'm looking at this part, I'm going to recall that a percent is a ratio that is comparing a number to 100. So I'm going to write it as 3 to 4 is equal to what out of 100? Okay, we're trying to find that percent, and I know that 4 times 25 gives me 100. So the same thing what I do to the denominator, I'm going to do to the numerator, and I get 75 out of 100, which is what? Which is 75% that I have just looked at. If the number is being compared to 100, which is less than 100, then the percent is going to be less than 100. So if this is less than 100, if the numerator is less than, the part is less than the whole, then yes, your percent is going to be less than 100%. And so this is 75%. Okay? Now, let us go ahead and compare 2019. And we're going to compare that to 2017. So we're going to compare 2019 to 2017. Okay, so in 2019, what was the part? This was, what is the ratio over here? This is how much we're looking at now. Okay, so we have 5 to 4. Okay, because in 2017 it was 4. So if I'm looking at the part to whole in this case, we are going to use equivalent ratio. I'm going to 5 over 4 is equal to what percent? So looking at this, I know that 4 times 25 gives me 100. And if I do the same thing to the numerator, I'm going to end up with 125 over 100, which is 125%. Okay, so percents are greater than 100% when the number being compared to 100 is greater than 100. And when the percent is greater than 100%, the part is greater than the whole. So let me show you what this would look like in a model. Okay, so let me show you what this would look like in a model. Go all the way. So this is what it's going to look like. So look, 125% means what? 125 per 100, and I can write it like this. There are three ways to writing ratios. You can write it with the colon, so 125 to 100. I can write it as 125 to 100, or I can write it like a fraction, which is 125 over 100. So if I'm showing 125%, I know that the 10 by 10 grid is nothing but 100 parts, right? And we had talked about that each square over here in the grid is 1%. So if it's 125%, we know that it's one whole plus another 25% in a different bar, in a different grid. So this is one whole, which is 100%, all right, plus 25% in the other 10 by 10 grid, okay, in the other 10 by 10 grid. So look, 100 plus the 25, and the total amount gives me 125%. And that is the model for the percents that are larger than 100%. So let's look at another question really quick. And if I say that, suppose the rainfall in 2020 is 5 inches. What percent compares the rainfall in 2020 to the rainfall in 2019? Okay, because in 2019 also we had 5, and in 2020 also, if you're going to have 5, so what rainfall is that? So it would actually be what? This is going to be 100% because it's the same amount, and the rainfall is in 2020, it equals to the one in 2019 because that was also 5 inches, and so it's because it's the same amount, it's 100%. All right, so let's look at identifying the percents, and we are going to look at this problem. All right, so let's look at this one. It's asking what percent is represented by the 10 by 10 grids. All right, so let's look at this. The percent compares the number of shaded squares to 100, and as you can see, because one whole grid contains 100 squares. So how many whole grids are shaded? This is one whole. This is another whole. So that is 2 whole grids are shaded over here. Okay, and how many squares are shaded in the third grid? So in the third grid, we have 10, 20, 30, 40, 50, 63. All right, so how many squares are shaded all together? So this is 100 plus 100, that's 200 plus 63. So 263 are shaded all together. Okay, so my ratio here, as you can see, we had said that this is 100, this is 100, and this is a 63 that we had counted. Okay, so when we have 100, 100, 63, so total amount 100 plus 100 plus 63, and I get 263 out of 100. Okay, out of 100. So the ratio is 263 to 100. We can write it like this also. We can write it like this also. All right. And therefore, what is my percent? Percent represented by the 10 by 10 grids is 263%. 263% is the answer for this one. Okay? All right. How can can you quickly determine the number of shaded squares in the grid without counting every square? So let's look at this. I know that the completely shaded grids, that is 100% because there are 100 different parts in there. It is one whole. So I don't have to go like 1, 2, 3, 4, 5, 6, 7, 8, etc. So I know the entire thing is 100 and each column in the grid is 10. This is all 10. So I should not be doing like this. Just each column is 10, right? So I can count the number of whole grids for hundreds and the number of whole columns in the partially shaded grid for tens and the number of squares in any partially shaded columns for ones to obtain the total number of shaded squares without counting every square. So let's look at another one. Let's look at this one. And what percent is represented by the 10 by 10 grid over here? Okay, so I can see I have one whole, so this is 100 plus 10, 20, 30, 31, 2, 3, 4, 5, 6, 7. So that's 37. Okay, so I have 137. That means this is 137 out of 100. Okay, and which is 137%. And this is what is being shown by this grid or represented by this grid. Okay, all right. So let's do a problem where it's asking me this. At birth, the average kitten weighs 5 ounces. At 3 weeks of age, the average kitten will weigh twice as much as at birth. Okay, so let's look at this. And the question is, write a percent that compares a kitten's weight at 3 weeks to its weight at birth. Then use the 10 by 10 grids to model the percent. So, at 3 weeks of age, the kitten will weigh how much? 10 ounces. Okay, 3 weeks, because this is at birth, is this much. All right, and at 3 weeks of age, it will weigh twice as much. So twice means what? 2 times 5, which is 10 ounces. Okay, and then we're going to write a ratio comparing the average kitten's weight at 3 weeks of age to its weight at birth. So this is at 10 ounces to at birth was 5 ounces, right? And so that's what we are comparing. And what we're going to do, we're going to do equivalent ratios because this is at 3 weeks and this is at birth. And then we are going to do an equivalent ratio and we are going to change it to a percent. And I know that the denominator in a percent is always 100. So I'm going to divide by 100. Okay, and so whatever I'm going to do to the denominator, I know that 5 times 20 is going to give me 100. Whatever I do to the denominator, I do the same thing to the numerator. Now 10 times 20, and that gives me 200 over 100. Okay, and so this is equal to what? 200%. Okay, so 200% is how much this kitten has grown, and all we're going to do is we are going to draw a 10 by 10 grid. So let me just show you the example. I mean, I can draw it out literally. It's like 2 whole grids, which will be 10 by 10, and if it's saying 200%, literally the whole thing is shaded in. Okay, the whole thing is shaded in. So let me quickly show you what this will look like if I was drawing it out. There you go. So look, 2 whole grids because we said that this is 200%. Okay? And suppose the veterinarian states that the kitten's weight increased by 100%. Is this claim correct? Why or why not? When talking about the kitten's weight, when is it correct to use 100% and when is it correct to use 200%? So think about that, and what I would say is the vet is definitely correct. The kitten's weight increased by 5 ounces, okay? Because the birth weight was 5 ounces, it increased by 5 ounces, so therefore it has definitely increased by 100%. However, when talking about how the new weight compares to the birth weight, then we are going to say 200%, because 10 ounces is 200% of 5 ounces. So just wanted to see, have a comprehension of that part. Okay, when to say 100%, when to say 200%. All right. So, if I am taking another question, and let's look at this one. At birth, a male baby giraffe stands almost 6 feet tall. At 4 years of age, the male giraffe will be about 3 times as tall as at birth. Write a percent that compares the giraffe's height at 4 years and age, 4 years of age to its height at birth. Okay, so if I'm talking about is going to be 3 times, that means it's going to be 300%. Okay, so let's look at this. There you go. All right, it's going to be 300%. And that's what the grid is going to look like. All right. Now, let's talk about percents which are less than 1%. Let's talk about percents that are less than 1%. All right. So, the distance from the center of the earth to the surface is also known as the radius of earth. The radius of earth is about 4,000 miles. The radius of the sun is about 430,000 miles. Okay? So the ratio of Earth's radius to the sun's radius is what? 4,000 to 430,000. Okay? And we can use equivalent ratios to show that the radius of Earth is about 9300% of the sun's radius. Because if I divide 430,000 by 4,300, okay, what am I getting? I'm getting 100. And then I'm going to divide 4,000 by 4,300 and I'm going to round to the nearest 100. So let me explain what that means. Okay, so we're going to talk about part 2 whole. So just want to show that to you. So let's look at this. Look. So part 2 whole, and all I could have easily done over here, I have 3 zeros, I would cancel the 3 zeros out. Okay, and then I have 4 and I have 430, so when I simplify, all right, and so, or I can just divide this by 4,300 and I end up with 9,300%. Okay, so my part 2 whole is going to be that much. All right, now percents are less than 1% when the number being compared. So I wanted to see this part. So look, percents are less than 1% when the number being compared to 100 is less than 1 whole, okay, less than 1, yeah. So when the percent is less than 1%, the part is significantly less than the whole. And the radius of the earth is significantly less than the radius of the sun. So if I was to draw this out, okay, we know that each part in a grid is equal to, each square in the grid is equal to how much? It is equal to 1, right? So if I'm saying 9300th, and I'm looking at this, y'all, each is 1. But since it's 9300th, look what that means. Out of this one part, 93 of these are colored in. 10, 20, 30, 40, 50, 60, 70, 80, 93. So in this part, we have 9300th. Okay? So on a 10 by 10 grid, 9300% is represented by shading 93 of 1 grid square. And 1 grid square represents how much? 1%. And 9300% is less than 1%. So compared to 100%, 9300% is significantly much smaller. Okay? So, when thinking about how the size of the earth compares to the size of the sun, it does make sense that Earth's radius is significantly less than the sun's radius just by looking at that. Okay? And Earth's radius is a little less than 1% of the sun's radius. So let's think about this. A classmate used a model and they went and colored in 93 parts over here. Okay, so not just 9300, they colored in 10, 20, 30, 40, 50, 60, 70, 80, 90 and 3. Let's say they colored in that much. What mistake did they make? And how does 9300% compare with 93%? So, the classmate who did this entire thing is representing what? They are representing 93%, 93 out of 100. Okay, so that is significantly much bigger compared to 9300%, because 9300 is way smaller or way less than 93%. So only that 1 grid square, 9300th part of that should be shaded, not 93 squares in this grid. All right, so that is the mistake that was made. Okay, so let's do an example over here. And if I look at this and I'm asked that what percent is represented by the 10 by 10 grid. So now we can see that in the grid only this teeny tiny part is colored in. So therefore it's definitely less than 1%, because each over here is what? Is 1%. So if only this portion is colored in, it's definitely less than 1%. So let's look at this. And we know that the percent compares the number of shaded squares to 100. And because one whole grid contains 100 squares. Less than 1 grid square is shaded on this 10 by 10 grid. And then the close-up of this reveals that only 1/4 of the grid is shaded. And 1/4 of the grid is what? 2500th. Okay, a quarter is 2500th of 1 grid square. So therefore we are going to write the ratio that compares the total number of shaded squares to one whole grid of 100 squares. So in this case, what is my ratio going to be? I can see that only this much is colored in. So this is my 1/4, right? And 1/4 is what? 2500th. So therefore, because this whole thing would be 1, right? But this is only this much, look. So that is nothing but your 1/4, which is 2500th. Okay, that is my ratio and out of 100. So if I'm writing this as, I can write this, or I can write this to 100, or I can say 2500 over 100. Okay, and if I'm writing this as a percent, represented by this 10 by 10 grid is what? It is 2500%. Okay, which is definitely going to be less than 1. All right, now A friend states that the percent represented by the 10 by 10 grid is 25%. How can you use reasoning to explain to your friend that this is incorrect? So, if I'm looking at this, if the grid represented 25%, then what would happen? Then I would have had this whole thing, this is 20, 1, 2, 3, 4, 5. So this much colored in, this whole amount would have been colored in, okay, if it was 25%, okay, but it is definitely not 25% because only 25/100th of one of the squares is colored in. Since less than 1 grid square is shaded, the percent modeled is going to be less than 1. Okay, so less than 1. All right. Let's look at another one. And let's look at this one. So what percent is represented by this 10 by 10 grid? So once again, I can see that we only have this portion colored in and this much is colored in. This much is colored in. Okay? Now we know that the whole square is 1%. So since this is less than 1%, because as we can see that less than 1 whole square is colored in. On a close-up view, let's look at this. How many? 10, 20, 30, 40, 50, 60, 70. Okay, so we have 70/100, or we can say we have 7/10%. Okay, because look, 7 out of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 rows, right? Or columns. So therefore, it is 7/10%. Okay, we can also say 7/10%. And basically, that's what this is. All right. Now, let's look at a problem where we are going to represent the diet of a jellyfish consists primarily of plankton, which are tiny organisms living in the ocean. One species of plankton has an average length of 400 inches. Suppose a certain jellyfish has a length of 8 inches. Okay? We are going to write a percent that compares the length of the plankton to the length of the jellyfish. Then we are going to use the 10 by 10 grid to model the percent. Okay? So first thing we're going to do is we are going to create a ratio, an equivalent ratio, comparing 400 inches to 8 inches. Okay? So we are going to write this to this. All right? So 400 to 8. All right? And that's in inches. And this is the plankton. And this is the jellyfish. This is the jellyfish. Okay? And then I am going to convert it to a percent. Make it 100. All right? And I know that I can do 100 divided by 8, or I can do times 12 and 5/10. If I divided 100 by 8, I would get 12 and 5/10. So if I had done division in this direction, I would have to do multiplication in the opposite direction. Okay? But in this case, I chose to multiply with 12 and 5/10, and then once again, whatever I do to the denominator, I do the same thing to the numerator, and I get 5/10, and this is my percent. This is my percent over here. Okay, so if I was to shade a 10 by 10 grid, all I would do, I'm just going to show you the shaded region. Okay, let's look at the shaded region. There we go. Just this little portion over there, because we had said that the answer is 5/10. That means it is going to be less than 1 whole. Okay, it's going to be less than 1 whole. And we can see that this is 1 and it is half of that. That is why it is 5/10%. Okay, so this is how much that you are shading in. Okay? All right, let's do one last problem. And let's look at another one. The average weight of a brown bear is about 1,000 pounds. Suppose a large stuffed bear weighs 2 5/10 pounds. And then I'm looking at, it's asking to write a percent to compare the weight of the stuffed animal to the weight of the brown bear. And then use a 10 by 10 grid to model the percent. So, let's look at this. It's talking about the stuffed bear, and this is the brown bear. So we're going to write a ratio out. We have 2 5/10 to 1,000. All right, and then we are going to look at changing this to a percent, and a percent, my denominator is always 100. All right, in order for me to get that 100, what do I need to do? I need to divide by 10. Okay, so I've got to divide by 10 because I've got to get rid of 1 0. And whatever I'm doing to the denominator, I'm going to do the same thing to the numerator. If I'm dividing by 10, I know my number's getting smaller, so the decimal is going to move one place to the left. And so this is going to be 25/100. And this part is my percent. So my percent is going to be 25/100%, or we can also say what? 1/4%. And remember, 1/4 is definitely less than 1 whole, right? And so if I had to draw this out, okay, if I had to draw this out, look, 1/4 of that teeny tiny square over there, because each square is representing 1, and that's just 1/4% that is being represented by this. All right, so again, this lesson is basically talking to us about percents which can be greater than 100% and can be less than 1%. Thank you. Have a great day, everyone.